In this chapter, we'll get into advanced drawing techniques. Alright, this is just all your objective. Yeah, we'll take a look at the drawings. Of course, not a regular one, but the advanced. Why this is advanced? Because we're using the special rules, not the regular rules. Of course, we're drawing the same thing in your part and then your view. I deleted it because you don't need this one. It's from your textbook. Okay, so let's go in here. So what are the rules that we're gonna follow? Yeah. So when we draw our views, we're gonna do the remove, revolve, detailed, partial, auxiliary, and related views. So these views are different from our standard 6 views. Yeah. Your top, your front, and then your right, your left, and then your bottom, and then your back. Yeah. Now we have additional views: removed, revolved. Not just the ortho, it's just your projection views. Yeah. Detailed views, partial, auxiliary, and then related. So let's see each one of them. Removed, revolved. Why do we have to do this type of special drawing? It's because we need to overcome your limited space. Yeah. Because your space is so limited in your drawing that you can't fit your normal principal views, your 6 views. Yeah, so at that time we're gonna draw the shorter version of it, and we call that remove and revolve views. Why we call that remove? Because you remove it. Yeah, you remove from the projection path, and then sometimes you have to rotate it to fit, and also to expose the views that you need to see in your part. Of course, we always label, yeah, because if you don't label, you're gonna get a confusion with your projected principal view. The best students do is confuse, right? So you gotta don't be confused. There's nothing to be confused about. You have your regular view. You have a limited space. You can do your projected regular views. At that time, we're gonna do the special views. Yeah, one of them is we remove. Yeah, and what are we removing? We're removing everything that is from the path to fit into that limited space. Yeah, sometimes we have to rotate and sometimes we have to scale it down. So that's what we're doing in these views. Nothing is different or yes, or difficult to draw. Yeah, it's just making it a little bit shorter version of the normal principal view. Okay, let's take a look at it. So here we are. This is a remove view because your part is pretty big, so we're gonna just remove it this part out of your regular original part. Of course, you have to scale it down. We're drawing 1:1 ratio, and my view is we'll remove it at this right cut section right there, which is AA. Yeah, so that's we call it the remove view. So we're gonna draw it from this side, so we can see this right there. We can see this little thing right here. See, it's not perfectly rectangular. It's kind of like yes, there is a inclined surface, internal inclined surface right in there. And then of course your rectangular, which is this guy right there, and that edge is all right here. Yeah. When you draw, I want you to go slow. Yeah, don't need to push yourself. Just go. I would prefer you get one. Yeah, one view draw perfectly, and then try to attempt like 6, 7, 8 with all kinds of mistakes. Yes. So here we go. So when I grade, I'll look for that. Yeah. So even though you're making like mistake for 3 of them, if you get like one of them, yeah, perfectly drawn and you kind of get it, you're okay. Yeah. So here we go. This is your little right there, this hole right here, yeah, circle. So you have a depth right there, so cylinder right in there showing with the hidden yes lines. Okay, this one is we revolve it. Revolve means you're rotating the view in a particular angle. So if you cut it up, but if you draw from the right side, like this, you will have a vertical line right here. But you can fit the vertical line on this drawing paper. You only have like this amount of limited space. So therefore we're gonna turn that 90-degree bang like this. So you get a horizontal, see, instead of the original vertical line. I want to show you why it is revolved. See, this is like straight standing up right there, vertical, yeah. And here we're turning 90 degree instead of the straight drawing. Yeah, see that? Okay. So students always have an issue again. The best they do is so confused. There's nothing to be confused about. I'm telling you again. This you draw it, yes, from the front. See, look at this from the front. This time no turning, so we call it just a remove because you're removing. Yeah, here there's a big cut right there. Here you cut it and then you're gonna revolve it, yeah, so meaning like you're turning it a 90 degree. In SolidWorks the same thing. Those students who are taking 121, right, we have a revolve. We said, oh, revolve, right? There's a revolve cut, so things like that. It's like you are turning, yeah, in a particular angle, sometimes 360 degree around, you turn it to close it, yeah. Sometimes it's just a 90 degree if you want to leave it open. So anyways, like that, okay? So then we'll get into detail views. Detail views is nothing, again, you are doing the drawing. So when you think about the detail, drawing has nothing but the dimensions. And then we're going to put the value to the dimensions. Drawing has your features on your part. We're going to draw the features on the part. So therefore, you always need to put the dimension. And you always have to play with the drawing space, yeah? And then your, of course, drawing and your dimension. And there are many different features, so you have issue putting that dimension in a particular way so it looks neat and tidy and clear, you know, to the reader of your print. So now detail views, it's just nothing but you just put in more, yeah, and fully dimensioned values into it. And it's got to be fully dimensioned because you're dealing with, again, different kinds of features. So right now we're going to deal with the small features, yeah, and that small feature again need to be fully dimensioned. That needs to be shown, yeah, with a bigger scale, of course, because you can see if you just show the feature, small feature as a small, right, with a small scale, the people can't read it. So we might have to make it bigger, yeah. And sometimes detail views, sometimes we gotta remove that from the projection pad and scale it down, yeah, scale it up, yeah, sorry, scale it up because you're dealing with the small feature. Of course, we always label our views. All right, let's take a look at the details view. See the little features like that, and here, oh my gosh, that's like a 0.80 for that height, and then you have another height right there. See, very, very small, and then that's like a 2.10, yeah, and then so and so. Some people are like crossing the dimension. I want you to don't like make this line go over that line, okay? Leave it. See, look at that, how they're not touching to each other. Try your best not to touch, right? Yes, I noticed like a couple of students, yeah, mixing up all the lines. You gotta pull it in, okay? Not just pull it out. So make sure you select and play with your mouse. Your goal for the semester is to be able to master handling your mouse, yeah, where you're clicking, where you're pulling or pushing, yeah, and these got to be, yes, you got to train yourself to get that with your application, yeah. Okay, so where is the detail? So now we're drawing this first, yeah. We look at from the top view, yeah, and then we have our front view right there, yes, drawing. So we're gonna take this section out, yeah, so we'll remove it, bang. So that is the section that we want to detail because you can't put all of your dimensions right in there, full dimension, yeah, because of the small part or feature right there. So we're gonna cut this feature out. So bang, you got a real big, yeah, real big a detail view of that part for this section, yeah. So now we can be able to put, see, the full dimension here for every feature change. So from here I change curve, then here, yeah, see, look at this edges, and then here we go, yeah, go all the way down, and there's your circle right there, your diameter, of course, and then your center, so that's your radius. And of course we are scaling it up, yeah, so we're drawing like 1:4 original 1, and you make it bigger 4, yeah. So that's what the scale is about. So you show, oh, this is my detailed view of A, and here, see that, don't forget this, So when you say, oh, the detail view of B, then it's got to be B here, yeah? So make sure your letter, label, got to match, yes? Where you're pointing it out. Don't do the leader line here, yes? Here it's just a regular solid label, yeah? For the for the detail view. Don't forget the scale, because you gotta put like how many times you're making it bigger, yes? This time 4. And the next view is your partial view. So partial views, we use them when you don't need to show the complete view. So if you can just show the partial view and that's enough for doing a particular purpose, then you go with partial view, right? So you don't have to like waste your time on drawing the whole thing. Of course, since it is partial, the name itself is partial, the views are incomplete, okay? Because we're not showing the complete view. Okay, so here is an example of your partial view. This is our part, of course, and you have all the features. So we draw the top and then your front. Yes, everything that's included in it. Because you have a little hole right there that you can't see on this side. There's another one. So if you pay careful attention, you can be able to see this little tiny hole right here. Yeah, and there's another one right on this side. They're supposed to show. See, I can pinpoint a mistake right there. It's supposed to be a little one. Maybe it's maybe at the edge or something. Yeah. Of course, and then here, yeah. So by this time, you should be able to see these things. Okay, yeah, center lines, and don't forget them. Yeah, and on this side, of course, when you look at top and then right straight down, then you can see all of this. Yes. Oh yeah, this drawing is no good. What am I saying? Like, this supposed to be actually the top, and that's supposed to be from the front. Okay. He's supposed. I don't know whoever drew this. This is wrong. I should change it back. So that's supposed to be here, and that's supposed to be up there. Okay, I'll fix it for you. Okay. So if I ever so if you ever like see this type of mistake, then you can quickly do it. Of course, and then we're going to take the partial view on. This is not a very good example as far as I'm seeing, yeah? But that's okay, you kind of get it. Partial view, we're going to take a feature out of that and then draw it in a particular view, either right, front, top, right? Depends on where you're looking at it. And it's definitely not going to show you the complete version of your part. It's going to show one of the. Don't get confused with the remove, by the way. It's a very different thing. Remove is the part that's been placed has already been removed, right? This is like the entire part, but we're drawing a partial, one of the feature out of it. So there is a big difference in between the remove and the partial view. So here it seems like it's showing only the partial view for your right side. Yeah, so you have your top and the front. All right, auxiliary view. Okay, auxiliary view we have already studied. Yeah, these views are like what we do is we project it at an angle from one of the primary views. So you have 6 primary views, and we're gonna project one of them. Yeah. You're going to project this auxiliary view at an angle to one of them, okay? And of course, we're going to show the features on true size. Your true size, true length, true angle. Again, some students have issue with the name of it. Don't feel bad about it. It's just the way that we say it. So features true size, true angle. It's a true, so it's the same size, yeah? All right, so let's take a look at it. Sometimes for auxiliary views, they can be partial, meaning like it's incomplete view, not the full one. Okay, so we're going to take an angle. Here is a horizontal line, so there is an angle right there, horizontal line. This line and this parallel, so the angle is the same. And we're going to project it, and that's your auxiliary plane right here. Yeah, so you can see like that way. See, a little bit different from the 90-degree right, from the right side. See how a little bit different that is, because there is an angle to it. See, this is like completely like straight in. And you can see this part. Since we want to show that part, we make a little angle and then project it, so we can see a little bit different. Here, of course, this one is not showing, so this is kind of like I would say like a combination of the top and the right, views are right in there, because you can see, of course, the dimension is a little bit different because this is longer. See, pay attention. Of course, we can see the top part, all of it, and also the right side part on it, when you angle it. So this is your auxiliary view example. Of course, that view is on your auxiliary plane. We have your primary plane of your front, top, right, and then the right. So these are your primary plane. Your auxiliary plane is at an angle to it. Okay. All right, on your drawing, where are we going to put this auxiliary view? We're going to put it just straight. So in MET 201, that's what we're trying to draw. So primary, auxiliary view, and your partial auxiliary view is right there. Partial is taking a part out of this, incomplete. This is full auxiliary view. We're just drawing this part right there, so you can see it clearly. Otherwise, there are too many hidden lines right behind. Some students are forgetting the hidden lines when you draw them, so be careful. Then we get into related view. So related view is going to show a part. Since the name itself is related, so we're going to hit the mating, so it mates. So the part that mates, but it's not a part of your detail being drawn. So we will concentrate on the mating part. Since they're mating, we're going to draw with the phantom line, type. Again, these views can be partial. So let's go in to the example, and here's our part. I think whoever draw this drafter K cap, I think some of the standard, they don't follow. They just draw, of course, so this is your front, and then this is your top, right? And then here is your right side. And the related view is showing, yes, right here where the mating part is going to fit in, yes? So you can see it. And we're using a phantom line to show the mating part, yeah? Of course, you can't see the mating part here. This is where the mating part is going to fit into this original part. And we call that the related view because it's showing the mating part. And we call this related part, yeah? Mating with your original part. All right, now this is just an example and trying to identify different views that we have just learned. So when you think about the principal views are normal views, so therefore you have your this one, which they call it view. Okay, we can just go with view B, and then this is your view D, and then your view G is your top and the front, and then your right side. Okay, so they're going with the letters, so instead of top, front, and right side. So we'll just go with the letter, of course. So B, and then D, and then G. You can also write it. Oh, that's the top, and that's the front, and that's the right. Auxiliary is something that has an angle, so therefore the only thing that has an angle is right here, View F. Detail view is the one that you're going to show all the details, of it, and usually is bigger, so therefore when you look at it, the only thing that is big showing the part, a feature, is right here. And see, look at this, it said B, detail B, so therefore this is your detail view. Your partial views are everything that's a chunk out, so we have little C view here. This is all chunk out, and then there's another one, another section that we chunk it out, which is view E, and then of course your view F is also partial auxiliary here, Okay, so that's all everything. So your views, auxiliary view, and then the partial view on the edge, Okay, so let's go to the next one. So this just is showing you how to draw your auxiliary view. So your principal views are here, and then your pictorial right there, ISO, and you're going to put it, yes, along that line. So these are your drawing lines right there, and you usually draw the partial or your auxiliary either partial or full right in here. In this example, they're drawing a full auxiliary. You're looking at it this angle, so you can see this, and then that, and of course the other one in the back of it. Okay, All right, we have casting, molding. I love molding because you can do a lot of shapes. And if you enjoy it, you can play with it. Yeah, look for it online, and you can buy these little molds in plastic. Usually, yeah, it's cheaper. You can also use your if you have clay, yeah, in your backyard or something. You can also use that to play with it. So here, yeah, we're putting. See, this is your mold. See how the shape, yes, can be molded. Your casting is here. Casting is something that come out, yeah, when you shape with your mold. Of course, you put some material to cast into the mold, to give it some time with and play with your temperature, yeah. Usually cool it down, yes, and you'll get that shape out of the mold. And here, this surface right there is your parting plane, okay. This is your chorus because see that how we have a little hole right there for the hollow ones, yeah. Okay. So anyway, that's how we do. Yeah, we cast and mold the parts. They can be created. And what we do, we solidify a molten material, yeah, and use a mold to do that. Okay, we're gonna draw it, and here we go. Your parting plane, of course, this is together, so you can see, inside. In your drawing, it's a little bit difficult, but it's all right, yeah. Your risers here, your pouring, so this is where you're gonna pour your molten material into this, yeah, mold, and you will shape it. Of course, there's a core right there because we want to make a hole, right, in your part. And then here, this is a section, yeah, it's cutting. So when you cut it straight up, right, straight up, and take it out and draw section AA, and you're gonna see that these are your material, yeah. And don't forget the material lines, yeah. Pouring cup, riser, core, and then your casting. Material of your mold, material of your cast, they're different. Why? Because the section lines are different. Okay, here we go. This is your bottle opener, yeah, your rough surface, your machine surface. This is before machined casting mold model coming out of the mold. You have your filler corner parting line is right there, yeah, a little bit rough. Then you want to smooth it out, yeah. So this is machined casting model. Machine surface right there. Machine surfaces are right here. Yes, that's cool. Okay. Okay, then we are going to communicate on what are we going to do about the surface, yeah? After manufacturing, of course. So if you draw like this, it means that your surface, you're communicating, yeah, your machining people. This surface is produced by any method, and you're going to communicate the people in the manufacturing process. Here I draw it like this way, meaning like materials removal is required for the surface, okay. And then if you draw like this with a little circle right in there, yeah, see, like a little check mark closed, and this one is a little ball right in the check mark. So in that case, you have your material removed, and that is prohibited, yeah. So meaning like don't do material removal on the surface. So when you come out of your casting process, and what are you going to do with the surfaces on that part? You're going to communicate your machining people, do this, do this, do this, yeah. Details, yeah. So you can put, so here are A, B, C, and then D, E, F, yeah. We'll go in order what to put. So here, if you put the number, yeah, like this, at this position in your drawing, you're communicating, hey, the roughness average value is this, yeah. You can be rough for this surface about this much, and then your maximum waviness height is going to be this, yeah. So your surface can be wavy about this much minus, and then your maximum waviness spacing, okay. That's just for machining the surface, yeah, of your part, and you have to put in. Don't worry about the number will you get it from the sheet. All you have to do is just draw and put the number as given to you, okay. So maximum waviness height, go look at your sheet and put that in. Maximum waviness spacing, put that in. Don't make mistake, okay? Especially the decimal. Yeah, decimal is a big thing, and we human have an issue. Yeah, as we age. If you read it like 2-3, you could write it 3-3-2 instead of 2-3. Yeah, that happened quite a lot. Yeah, in real life situations. So make sure you, after you put the numbers, you have to check if they are exactly the same as what you get from your sheet. Okay. Yeah. So dimension sheet, of course, or your value sheet, whatever you want to call it. Make sure double check, triple check, because people make mistake. Yeah, it's called human error. We make mistake like that. Yeah, I make mistake too. Yeah, sometimes you write like MEXI, but then in reality you wrote it like MEIX, right, instead of XI. It happens a lot to everyone. Okay, so roughness. Yeah, maybe typing sloppiness or whatever. So D, little d is your roughness, sampling length, yeah. And then your lay symbol, and then your machining allowance is going to be here. Again, don't worry about the values. Value will be given to you. All you have to do is know which value go where, yeah, in your drawing, and then stick it into there. That's it. And this is the only one that you use symbol at the E position, and that's called the lay. Remember, like some people, like for manufacturing, like if they're working, you can hear like layman, right? So they have to do this machining, according to the values right here. Yeah. So this one is your lay symbol. Okay, so let's take a look at where we're gonna put it. So our normal, yeah, drawing, and then of course here the surface. See, we're putting the little surface texture symbol right here, here, here. Yeah, see that? And that's just showing you your parting line on where you close your mold. Okay, and then of course this will come out after you cast. This is your notes, what to do. Yeah. Um, this is just showing you that you draft all around that part. And here notes, unless otherwise specified, you're gonna follow 1 and 6. You communicate it to your machinist. Yeah. We put our standard as usual, dimension and tolerance. In this case, they exclude it. Yeah, exclude the draft, of course, and talking about all your fillet radii, yeah, to pay attention when they do it, when they work on that part. Corner radii to pay attention. This is just your little R radius sign for the value, yeah. And your draft angle is about 5° max. And your die is going to be close allowance. Of course, die allowance, you write it right here for them. Don't worry about this anyway. It depends on where you're working, okay? This is just, okay, if you know like, I have to put the note right there, and this information will be given to you when you draw, yeah? And then of course, I'll put the surface symbol where they're needed. All right. And the last part is your weld parts. So welding is a part of your manufacturing because you have to join the pieces and you're dealing with the metal. Yeah, in order for you to join the metal, you have to weld. Of course, welding includes your heating. So you gotta wear your protective, coverings, your face and your hands and your body, because the heat that you are dealing with to melt the metal is very high temperature. Yeah. So how do we get that type of temperature, high temperature to melt the metal? We use the blowtorch, electric arc, and other a technique. Sometimes you have to use a filler rod. This is just a welding process in order for you to weld the joint, all together to make sure that they stay together. All right, so let's take a look at the very welding, welded parts. So the very first one is in your drawing, of course. This right here, see this little gray, section? It's just showing you where you weld, so that's your welded part. And this one is your fillet, because you're welding your fillets, so therefore this is a fillet weld. That's just showing you the dimension. Your leg is about 8 millimeter, on the other side. And we're going to draw it on this right side view. Yeah. And here we show the lake, which is here. That's your weld, yeah, on this side, on that. And that's 8 millimeter we welded. A lake mean how much you welded in between that joint. Okay, up. And that's 8 millimeter. 8 millimeter is not long. Yeah? And then another fill-up weld. You decide, yeah, if that's a fillet or V groove or square groove by looking at where we're welding. Yeah, these are all fillet. And you have to weld to different values. So the very first one, yeah, it's your 6 millimeter. Yeah, it's your arrow side, and then 12 millimeter, which is the other side. Okay, arrow side mean here on this side. This one the same, yeah. So we have two different things going on. Arrow side goes low, and the other side go up. Yeah, be careful. We tend to put the arrow side up, by the way. So you're supposed to put this down, yeah. So it just sometimes, yeah, studying is hard because you gotta pay attention to the things. It's usually crisscross, yeah, and sometimes flip. So when you study, you gotta pay attention, and our brain has inertia. You know, we wanna do the same thing as we saw. So if you're taught this way, the next one you tend to put it up, yeah, but don't do that. Okay, so fillet weld, another, yeah, because it's joining the two parts right here, and it said leg is 6 millimeter all around, yeah, from here all the way to the back. So just put an arrow right in here. We're gonna use a different little symbol because it's just down, yeah. Here is up, up. Now we're showing the down at, yes. Weld is from the bottom, and you're gonna put it down, and the leg is going to be 6 millimeter. V groove. It looks like a little V, yeah. So we'll put the arrow, and then show the weld is a V groove. Yeah, with a little V, inverted V. Square groove weld, yeah, arrow side. This is your square, and you're gonna weld it so they join together. And we weld it right here, and we use a square, yeah, groove welding process right there. Bevel, yeah, bevel groove weld on both sides. There's top and the bottom. So now they're together, yes. We weld it, and then we're gonna put a look, kind of looks like a little K, yeah, and set it. Oh yay, we did the bevel groove, yeah, on both sides. If it is on one side, you're gonna have a little, yeah, and up, but not a groove like this. But see, like one is straight down, the other one has at an angle, yeah. Okay, so this is just showing you how to draw your answer. This is one of your exercise anyway, because you have to do all the exercise, yeah, from your lecture. And some of you know like where to go on the website. Some of you still don't, struggling. So anyway, so your answer's right here. Yeah, I give it to you, so you kind of get a practice of how to look at it and draw it. Don't just copy it, look at it. Yeah. So we're drawing from here for your auxiliary view, yeah, which is this guy. These are our principal, which is your top, front, and your right side, yeah. And of course, it gets complicated because you have internal features right in there, yeah. All right, that's it for this chapter. It's a very small chapter, so we're down to 3, yeah, for the rest of the semester.